Hello, and welcome to Module 6, Lesson 2, which is wind. All right, so the focus question today to think about while we're going over the notes, how do humans' activities affect wind erosion? So wind erosion obviously is from the wind, usually doesn't involve gravity or water. It could, but more than likely just the wind. All right, so if we think about wind, the velocity makes a big difference. So velocity is the speed and direction. So if we look at the first car, speed is just how fast you're traveling. So maybe that's 5 miles per hour. But velocity is in a given direction. So it could be 5 miles per hour west. Then that would be velocity. So the only difference is direction. So with wind, that makes a big difference. All right, so if we look at this example here, this picture of the US, it shows wind erosion and where it's most commonly found in the US. So wind can happen anywhere. But if we look at topography makes a big difference. So if there's mountains help to protect areas from erosion. Areas that are very flat, no, not mountainous, are kind of prone to erosion because the wind can move over large spans of land. So if we look at the US here, areas where we don't have a lot of mountains, we have a lot of wind erosion. So throughout the whole Midwest here, and then we have little pockets like this is the Sacramento Valley here, and little pockets where there might be very little vegetation. Maybe it's very dry. Vegetation helps to hold the soil. And so if there's very little, then the soil can just blow away, or sand, whatever it is, can blow away. So you can see this pretty much corresponds with where we have areas that are not a lot of mountains, and maybe it's barren or grassy or something along those lines. All right, so a huge wind erosion event that we had in the US was in the 1930s. It was the Dust Bowl. I believe I've showed you a video of the Dust Bowl, a little clip of it. But that was basically a combination of poor farming practices, and it was also drought. So severe drought for several years mixed with poor farming practices, like not implementing windbreaks, leaving the ground fallow, meaning nothing's on it in between seasons. And then mix that with drought and severe wind, and you've got a huge issue. So in the picture on the bottom, that is just all dust. So that's soil, dust, pretty significant, pretty crazy. And it would blow, it ended up blowing several feet of topsoil away. And like you learned with the soil worksheet, it takes anywhere from 100 to 400 years to produce about an inch of soil. So that's pretty long to produce an inch of soil, and we need a lot more than an inch of soil in order to grow things. So that's called deflation, when you have particles being removed from the ground. It's called deflation. All right, so another process is called abrasion. So abrasion is occurring when you've got particles scrubbing onto other particles, so scratching it basically. So if we think of wind in the desert, we've got lots of wind blowing sand around, and sand is really scratchy, and so that's really abrasive, kind of like sandpaper, for example. And so mix that with sandstone, which is very common in the desert, we get really unique kind of cool structures forming. And so those structures are called ventifacts. And so in the pictures at the bottom, you can see we've got arches. So in Utah, Arches National Park is pretty significant, pretty cool. And then you've got these weird kind of rock formations here. And basically that's just because the sand is scratching and eroding different areas of the rock. And so this might be a harder rock up here. This might be, softer rock. And so you get these weird kind of formations occurring. All right, and then we've got deposition occurring. So deposition is basically, you've got deflation, right? So deflation is when the soil, sand is moving, and then it gets deposited somewhere. So that would be deposition. And so when it gets deposited, most commonly we think of sand dunes. And so sand dunes are just when the sand is blowing and accumulating somewhere else. And so there's a couple different terms down here that you should be familiar with. So there's saltation, which is the bouncing along on the ground of the sand. Suspension is when it's in the air. So on a really windy day, for example, you can see not necessarily sand particles, but you can see soil or dust or things in the air. So that's suspension. But once it falls to the ground, then it's deposited. If it's just kind of bouncing like sand, for example, it'd have to be extremely windy to have it be suspended. But usually sand will kind of bounce and move along the ground, and that's saltation. And then creep, think of creep as like the really heavy rocks that are kind of just rolling on the ground. They're not going to be suspended unless you've got like extreme wind conditions. So those are some terms that you should know. Suspension in the air, saltation kind of bouncing along the ground, and then creep is just kind of rolling along the ground. All right, so if we look at this sand dune, we can tell which direction the wind is moving. So notice how on this side it is smooth, and then on this side it's kind of this like dumping, like a cliff kind of. And so that's the leeward side. That is not on the wind side. So windward would be kind of smooth, and it just has to do with how the sand particles are moving and how they're deposited. So windward side is going to be very smooth, and then you've got kind of this sharper edge, and that's our leeward side. So we can tell what, even if the wind's not blowing, or even if we look at petrified or preserved sand dunes, like like sandstone, for example, we can tell which direction the wind was blowing at the time that they formed. And that's because of this difference in leeward versus windward side. All right, so there's 4 different types of sand dunes, so you should be familiar with each sand dune. So the Barkin sand dune, it forms these crest shapes. So you can see in this picture here, this kind of like half moon or moon shape. And it's usually a small amount of sand, so it's not ginormous amounts of sand. And they form these ridges. So you can see here, this would be our windward side. This is our leeward side. And then basically these flat areas back here, you can't really see it too well, but they are in the wind direction. And they have crests that point downward. So you can see this crest points kind of in this half moon shape. Oops, a little bit far. All right, and then transverse dunes. These are kind of swirly shaped. So they're kind of irregular arm shapes, kind of like this. So this is an irregular arm. We can tell which side the wind is coming from. The wind is coming from the right. So if we take a look at it, this is our windward side. This is our leeward side. So notice how it's a steeper drop. And then the winds maybe are mixed up. So the wind could be kind of whipping through through different seasons. In this case, the wind is probably coming down through the mountains and creating kind of a swirling effect. So that would be transverse. And then parabolic dunes, this is real common on the coast. So you can see we've got some vegetation. It's not complete desert. They form U shapes. This would be very common in the Monterey area. So if you go anywhere down there, Santa Cruz, Monterey, very, very common. But there is some minimal vegetation, so there's not as much soil erosions than there is for the other sand dunes, because if you notice, the other sand dunes had no vegetation at all. So this is kind of a along the coast kind of sand dune, so parabolic. And then the last one, longitudinal. So notice how this kind of ripple effect. And so this would be basically, you can see there's very minimal vegetation there, but they form parallel to the wind direction. So the wind direction would be going this direction. And so this is a really long span of area where the wind blows. And so you just get kind of this pattern. And often these sand dunes are not found by themselves. So you would see all 4, or maybe all 3, maybe not the parabolic, but you would see all 3 of the others, the ones without vegetation, in the desert. So you're not going to see just one. Often it's a combination of all the sand dunes. All right, and then if we look at deposition, so we said that wind depositing ground or soil or sand is going to obviously be deposited. It's moving from one area to the other. And so where we have a big distribution of soil or sand or anything that's blowing into the wind, it's going to distribute that it could distribute even across the U.S. So during the Dust Bowl, the most significant area of the Dust Bowl is right in here. That's where we lost a lot of our topsoil, but that topsoil blew all the way over here, which is kind of crazy. That's pretty far. So these sandy areas are where the dunes are found. So we can see along the coast, we've got our parabolic dunes. We do have some in Nevada. There's very, very small where it wouldn't register on this. And then we've got some sand dunes here, and there's vegetation here. So we would see some more of the parabolic. And then we've got loess. So loess is where you've got this dirt that's deposited. So it's kind of this sandy, loamy mix. So it's mixed with soil, but it's also sandy. It actually makes some really excellent soil. And so this is what loess looks like. So this was found in the Midwest. And you can see there's a huge A layer. So this would be considered our A organic layers here, and then our A layer. And that is just really, really fertile soil. So we get a lot of that deposits. You can see loess deposits are this orange color. And so we happen to have extremely fertile land right in this area. This is the Midwest where we do a lot of our agriculture. And so that happens to be because that's where a lot of this wind deposition occurs. So that's what makes this really fertile, nutrient-rich soil is this transported soil from numerous places. And that is it. So I will see you next time.